Hey guys, today we're going to be taking a look at trigonometric derivatives. So we've looked at a few different rules over the past few days. We've seen the product and the quotient rules and the power rule. There's another big one called the chain rule, which we'll look at next. But before we get there, we are going to look at trigonometric derivatives. These are derivatives that you are going to need to memorize them well because they'll be reoccurring throughout the entire year. Sooner you memorize them, the easier it will be really the rest of the year. So with that, let's go ahead and jump in. So there's 6 primary trig functions that you need to memorize. Obviously, sine and cosine are used more often than like secant and cotangent. However, you do need to know all of them because you will be asked to find the derivatives of all of them. So again, memorize this table, which I'm going to go over. The first one, the derivative of the sine of x is cosine of x. That's an easy one. The derivative of cosine of x is minus sine of x. The derivative of tangent is secant squared. The derivative of cosecant, this is where it gets a little bit more challenging with these three, is minus cosecant cotangent. The derivative of secant is secant x tangent x. And the derivative of cotangent is minus cosecant squared. So again, these all need to be memorized. Can't stress that enough. You have to know these. You memorize them the more that you use them. So doing extra practice problems is a great way to memorize them. But if you're just good at studying them, do that as well. So I'm going to do a series of 8 or 10 problems here utilizing these. We're also going to incorporate some of the previous rules, the power rule, the product rule, and the quotient rule. We're going to incorporate those into these derivatives to get a little practice on those as well. So with each of these problems, I would even recommend pausing the video and trying it on your own first, give you some extra practice, and then I'll incorporate a few of them that you do have to answer for that puzzle. So let's go ahead and get started. Again, we're just going to, if you, for right now, might even want to have a list of all of these, just have a little table next to you as you compute them until you get them memorized. But we're just going to apply some of the rules that we've learned and see how this all works. All right, so here's our function f of x. So f prime of x with the notation that we use. First of all, if you have a constant in front of any trig function, it just kind of hangs out there. In the same way that if you were to do like 3x squared, the derivative of that, really the constant just hangs out in front and you bring the 2 down, it becomes 2 times x to the first. And then you end up multiplying it. We kind of just do that in one step. However, it's a trig function, there's nothing to really multiply it by, so it's just going to sort of hang out in front there. So the derivative of cosine is minus sine. So this ends up becoming 2 times minus sine x. Okay. And traditionally, we actually just go ahead and write this as minus 2 sine x. You'll get the hang of that the more that you do it. We then have minus 6, and that just sort of hangs out in front. The derivative of secant is secant x tan x. And then the derivative of 3, well, is just 0 because the derivative of any constant is just 0. So we end up with just minus 2 sine x minus 6 secant x tan x. And that's it. There isn't as much simplifying to do in this, so that's good. All right, let's go and look at the next one. We've got g of x is 3 secant x minus 10 cotan x. So we're going to write this as g prime of x equals 3 again just hangs out in front. The derivative of secant x is secant x tan x. So 3 secant x tan x minus 10. The derivative of cotangent is minus cosecant squared. So this becomes negative 10 and then minus cosecant squared x. One thing I wanted to mention as well, when you write minus cosecant squared x, this is the way we write for trigonometric functions. This is equivalent to saying minus cosecant of x quantity squared. It's kind of the same. Actually, sorry, that's neither. It's like minus cosecant of x squared. In the same way that like saying secant squared x is actually secant x quantity squared. That's kind of how we write that. So that's what it means, as opposed to if we had like secant of x squared, that implies secant and just the x part is squared. But when we write it as secant squared x, that actually means the whole function is squared. So with this minus cosecant squared, it's like parentheses cosecant squared and then the minus on the outside. Just a notation thing there, so you're aware of that. All right, so then when we write this, it's just 3 secant x tan x. Two negatives become a plus, so it's plus 10 cosecant squared x. And that will be our answer. So those two negatives become a positive. Another one. This one is h of t. So when we write this, it's going to be h prime of t. We've got just a standard power rule there. T cubed is 3t squared. Now this one, be careful, because this t squared is not a constant. That is actually its own function, which means we need to apply the product rule in this case, because we have one function times another function. So a couple ways you could do this. You could just, if you want to leave the negative out and just sort of view it as like this, you can do it that way. I'll do it that way for this one. So I'm just going to leave the negative out and just put a big thing in parentheses. And then remember with the product rule, if it's f times g, that is f prime g plus fg prime. So this becomes 2t, because that's the derivative of t squared, times sine of t, plus t squared, original f, times the derivative of sine, which is cosine. And then we should really get rid of the parentheses there. So this would become 3t squared. We got to distribute this minus sign through. So minus 2t sine t minus t squared cosine t. So that is our answer. I prefer to leave it this way. I guess sometimes you might see that they would potentially factor out a t. I think it looks a little bit more confusing that way, but you could theoretically factor out a t, so then it would be 3t minus 2 sine t minus t cosine t. Suppose you could see the answer that way as well, but I like the first way better. All right, next one. This is h of w. Okay, so notice completely different variables here, but it works the same way. So h prime of w. Well, we got just a standard power rule here. We're going to multiply this exponent down, so that becomes negative 12 w to the negative fifth, because we're subtracting a power. We then again have a product rule here, because w squared is one function, that's our f, right? And then the g is tangent of w. So minus parenthesis, the derivative of w squared is 2w, tangent of w, plus w squared, derivative of tangent of w is secant squared w. We then need to distribute that negative symbol through. So negative 12. And since they gave us negative exponents, it's okay to write our answer with negative exponents. So minus 2w tan w minus w squared secant squared w. Okay, next one. Oops. Somehow I skipped a bunch of them there. All right. Let's go ahead and look at this. This is a product rule with two trig functions. When I do this one, it's going to be y prime. I prefer to look at this first part, 5 sine of x. That's sort of my whole f. And then this one is the whole g here. Another way would be to just completely ignore the 5 and just sort of keep it out on the outside. Either way you want to do it is fine. But again, I just kind of prefer to lump that 5 sine x as one whole function. All right, so if I do f prime first, derivative of sine is cosine, so this becomes 5 cosine x times cosine x, because that's g. It's 5 cosine x plus my original first function, which is 5 sine x. The derivative of cosine is minus sine. So minus sine x plus, so that's my product rule, my first two functions there. But I still got this left over here. The derivative of 4 cosecant x would be negative 4 cosecant x cotan x. All right, now this one we can't just leave like this. When you see cosine x times cosine x, well, we can actually write that as cosine squared x. So we're going to write this as 5 cosine times cosine is cosine squared x. Again, we write the cosine between the s and the x there. And then we also have a sine times a sine with a negative out front there. So this becomes minus 5. And that would be sine squared x. And then we got a minus 4 cosecant x cotan x. Sometimes it's tempting to combine these steps into one step. I wouldn't really recommend that, even if you have to write more. It's just very easy to make a mistake if you try to combine steps. So I would advise writing it out this way and sort of keeping it separate and then combining it at the end. A lot less chance for error that way. All right. Let's go ahead and move on to the next one. So for the next one, we've got a quotient rule. Remember, fractions are quotient rule. It's quotient rule. Remember, with a quotient, it's f over g. That's f prime g minus fg prime over g squared. That's our quotient rule. Similar to the product rule on the top, except it's a minus sign instead of a plus sign. And then the bottom is the original denominator squared. So this is going to be r prime of t. The derivative of the top, remember this is f, and the whole bottom is g. Well, the derivative of 1 is actually 0. So 0 times the original bottom, 2 sine t minus 4 cosine t. And we know that's going to end up being 0, but I'm going to go ahead and write it. It's good to just practice these rules. Minus original f, which is 1, times g prime. So the derivative of the bottom. The derivative of 2 sine t is going to be 2 cosine t minus 4. Derivative of cosine is negative sine t. Now notice I did just do minus 4 and then the minus sine t in the parentheses. Again, it's a good idea to just keep those separate and combine them on the next step. It's also just showing that you know how to apply these rules. All right, so that's my numerator, and I also have to do it over g squared. So I'm just going to do a big 2 sine t minus 4 cosine t squared. And then simplifying this whole thing goes to 0, because it's 0 times anything is 0. And then this negative 1 we can just sort of distribute through. So that becomes minus 2 cosine t. This would have turned to a plus, because a minus 4 times negative sine t would turn into a plus, but we got to multiply by negative 1. So overall, 3 negatives make a negative 4 sine t. In the bottom, we're not going to try to multiply that in any way. We're just going to leave it as 2 sine t minus 4 cosine t squared. That will be our answer. Okay, next one. We got a quotient rule again. Just to remind you, it's f prime g minus fg prime over g squared. The top is our f, the bottom is our g. So this is going to be p prime of t. represents our derivative there. Try to make sure you're writing this notation as well. Just don't write equals because you're not telling people what you're doing if you don't write the p prime of t. So the derivative of sine is cosine. So cosine of t times the original bottom, 3 minus 2 cosine t, minus original f there, sine t, times the derivative of the bottom. Well, derivative of 3 is 0. That just goes away. Minus 2 cosine t, so it'll be minus 2. Derivative of cosine is negative sine. I realize you won't be able to go quite this fast. You probably don't have these memorized yet, but take your time. Look at your sheet if you need to. And then over the bottom squared, 3 minus 2 cosine t quantity squared. We could definitely do some simplifying with this one. We'll probably want to go ahead and distribute this on the top. So that would just become 3 cosine t minus 2 cosine squared of t, because we got a cosine times a cosine. We'll distribute this other one on the top. That becomes a, let's see. Well, that becomes a positive 2 sine t, so overall it becomes negative 2 sine squared t. Looks good. Over, we'll just keep the bottom, 3 minus 2 cosine t squared. There we go. All right, we got one more. Oops. Yep, we're going to do one more here. All right, let's go ahead and try this quotient rule. So it's going to be z prime of v, the derivative of the top, that's f. So this is v, so the derivative of v is 1. So it's going to be 1 plus derivative of tangent is secant squared, so secant squared v, times the original bottom, 1 plus cosecant v, minus original top, v plus tangent of v, times the derivative of the bottom. Well, the 1 goes away. The derivative of cosecant is minus cosecant cotan. So, sorry, guys. So it is just minus cosecant v cotan v over the bottom squared, 1 plus cosecant of v squared. I don't think you probably want to FOIL all those out. So I'd actually probably just leave this one as is. You have to FOIL the top and FOIL both of those on the top. That doesn't really seem that reasonable. So we'll leave it as is. I think there's one other one that somehow I missed when I was clicking through. My thing doesn't work. Actually, there it is. I want to do this one. All right. So last one here. We'll wrap it up with this one. Finding y prime. So with my first part, you always want to sort of separate these between the plus and the minus signs. So think of this as one thing, right? And then the rest of this as one thing. So look at the plus and minus signs and try to separate it between that. So the derivative of 6 is just 0, so that's going to go away. However, I do have a product rule here because I have two functions. They're multiplied here, and I would think of this first part, this 4 square root of x, think of that as your f, and then think of the cosine of x as your g. If you wanted to, you can just pull the 4 out and then do your product rule from there. But again, I like to just sort of keep it incorporated with that first variable. So I'll show you how to do that as well after. All right, so the derivative of the first part, it's f prime times g plus fg prime. I would also maybe write this as 4x to the 1/2, just sort of rewrite that before you do it. And then we want to convert it back to our root form there. So it's going to be 4 times 1/2. I'll just write out everything here. 4 times 1/2 x to the negative 1/2 because we subtract 1 from the power. So that's f prime, and then it's times g, so cosecant x plus our original function there, 4x to the 1/2, times the derivative of cosecant, which is minus cosecant cotan, cosecant x cotan x. All right, so then let's try to simplify this a bit. This 4 times a half just becomes 2. And then, actually, before we do that, it's going to become 2. And then that goes to the bottom. It becomes over square root of x. So we would just write that as 2 over the square root of x. The 2 stays on the top, and then the negative exponent takes it to the bottom, and the 1/2 becomes square root. So 2 over the square root of x. And actually, we can throw this cosecant on top too, because that's multiplied times that. So 2 cosecant x over the square root of x. And then with my other part here, we've got minus 4 square root of x, and then really just times cosecant x, cotan x. This don't always look pretty, but that should be how we want to write our answer there. The other option which I was talking about, if you want to just sort of pull the 4 out in front when you do this, just be like y prime equals 4, and then just do 4 times, and then just sort of look at the square root of x as your f. So then it would just be 1/2 x to the negative 1/2 cosecant x plus x to the 1/2, and then minus cosecant x cotan x. And then you just multiply the 4 through at the end. So then you just distribute the 4. So 4 times a half then becomes 2 cosecant x over square root of x. And then 4 times that plus 4 square root of x. So this becomes minus cosecant. So either way you want to do that, if you want to pull the 4 out in front, or if you want to just sort of keep it with that first function, choose however you prefer and go from there. All right, take your time on these. I think you've got about 10 problems to practice this. It also is practicing your product and quotient rules as well. Really take your time, do your best that you can on this, because these are skills that you use throughout the year when you're computing different things. So, and as always, reach out to me if you need some help. I'll try to post the answer key for this section before too long as well. All right, good luck.